Hi, I'm Briz, and this is NetNet, and in the last couple of videos we introduced you to HTML, or Hypertext Markup Language, which is the foundational language for creating the World Wide Web, this platform that we're on. The World Wide Web is, as I described in the orientation tutorial, a metamedia commons. By commons, I mean that it belongs to all of us. There's no one company who controls the web or one country who controls the web. There's no single data center that the web exists on. This is something that I've been hammering on the last couple of videos and that I'll come back to at the end of this video. But for now, I want to focus on the first part of that phrase, the metamedia part. This is a term that I'm borrowing from a group of creative technologists, researchers from a research lab called Xerox PARC, where in the 1970s, they expanded the possibilities of what computers could be. At that time, computers were mostly just text on a screen, whether that were words or code, and the people using them were mostly mathematicians and engineers, and most folks didn't really realize that computers could be much, much more than that. And the folks over at Xerox PARC, and honestly a lot of other creative folks in this era, the 70s was a really interesting time for computer innovation. They realized that the computer was this universal machine. In Xerox PARC, they called it a metamedia, which they describe as a new kind of medium whose content would be a wide range of already existing and not yet invented forms of media. So that first part, the already existing, what they were pointing out was that on the computer, we could have not only text, but also video, but also sound, like all these other media that existed before computers. They could all inhabit this one machine, whereas before, those forms of media had to exist on separate devices, separate machines. They could all now come into this one place. And they don't just mean, as we do now, that there could be software for working on video and software for creating music and software for creating images. That is typically how we interact with it today. We still kind of compartmentalize it. But they were trying to explain that this medium could be all of those things all at once. And the web stays true to that original vision. On the web, up to this point in the lessons, I've only shown you text, but we can bring in images and video and even forms of media that have not yet been invented. And that's because through code, we can create brand new forms of media. And I also want to, at the very least, hint at how that's possible on the web in this video. So I want to introduce you to a few more HTML elements that bring in these other forms of media into the web. In the last video, I showed you that you could find all of the elements. If you open up NetNet's learning guide, there are docs for all of the different coding languages. In HTML, you find these docs right here. And this includes docs which list out all of the HTML elements and attributes. Now, I'm not going to go over all of the elements. Nobody has all of these elements memorized that I know of, but I'll introduce a few that are usually of interest to artists and designers, which are these other media elements to create images, videos, sound on the web. And I'm going to introduce you to those elements through another one of NetNet's learning modes. In the last few videos, I've mentioned that here in the docs, netnet.studio/docs at the bottom of the Dear Students guide, where it talks about the learning guide, I mentioned that there are these different modes of learning on NetNet. We have interactive tutorials, like the orientation tutorial from before and some other tutorials I'll be posting in the coming weeks. We have the guided intros, like the guided intro to HTML, which if you didn't see that video, you could just launch yourself by opening up the learning guide and clicking this button, and NetNet will introduce you to all the core concepts behind HTML. We also have guided templates. So in the last video, we went over this guided template. A template is just a starter project, but on NetNet, we can also have NetNet guide you through the creation of that template. So the template also becomes a lesson, which helps us understand some core concepts. In this case, it was the conventional structure of an HTML page. And lastly, we've got annotated demos. Annotated demos are single file sort of examples that are also annotated that NetNet can kind of explain and guide you through. And we're going to be going over these, the image, audio, and video, which are linked here in the learning guide, but also at the very bottom of the learning guide, which you could jump to using the table of contents here. There's a link to this demos widget. If we open that up, you can find all of the demos on NetNet, and we're constantly adding more. If we search through here, let me make this bigger. You notice there's a long list of demos. Some of them have dots next to them, some of them don't. The ones that do have dots means that these demos are annotated. They're examples that NetNet can explain to you. When you click through one, this is the image one we're going to start with. You can see at a glance what the code looks like, what the output looks like. You can even edit this code. If I were to delete all but one image, you'll notice that takes effect. And in order to go through the annotation, the sort of NetNet guide, we're going to want to open it. Now we can open it in this window or in a new tab. Sometimes you might be working on a project in this window and you don't want to replace your project with a demo, so it makes more sense to open it in a new tab. But in this case, I'm not working on anything, so I'm going to go ahead and open up the demo right here in this tab. Once a demo is open, we should see an interface that looks similar to the last video, to our guided templates, except rather than building out a whole template from beginning to end, we see the code all at once, always on a single page. Templates could be multiple code pages and files. It can be much larger starter projects, but a demo is always a single file sketch, oftentimes with annotations that NetNet can walk you through. So we've got the sketch demo guide. We can use this to skip around to different parts of the guide. And if we ever close this at any point in time, we can always reopen it, because the other thing that we get when we're in an annotated demo, similar to the templates from the last video, is this guide button at the top, which has the name of the demo we're working on and the button that'll reopen and relaunch the guide. We can also skip around. We don't have to go from beginning to end when we're in one of these guided demos. On the editor, you'll notice that NetNet's got a few green dots. If you click on any of those green dots, NetNet will tell you about that very specific part of the demo, which if we look at the timeline here, eventually NetNet was going to get to towards the middle of this guided lesson. But what I'll do is I'll go right back to the beginning and we'll start this guided lesson from the beginning, this annotated demo. So here NetNet mentions that this sketch demonstrates a few key principles of the IMG element. Though most elements have an opening and closing tag, the IMG, or image for short, is one of those few elements known as a singleton or void element, which only consists of a single opening tag. We've discussed a few of these already in the previous videos. The image element, which is, of course, how we bring in images into our otherwise text-only web pages, has two attributes. The first one is the src attribute, this one right here, which we use to specify the image file that we want to place inside of this element. And the second is the alt, short for alt text, which is used to provide alternative information for an image if a user for some reason can't view it. And we'll come back to why that might be the case a little bit later. So on this page, as NetNet mentions, we've got lots of image elements. In this demo, we have 22 to be exact, but they all use just one of two sources. So there's only two image files that are being used, and they're just being duplicated over and over again using multiple image elements. The first one is called Dancing Girl GIF. I can click on this just to view that image in a new tab. Here's the URL to that Dancing Girl GIF image. And the second one is called Dancing Girl BW, or for black and white. By adding more image tags, you can instantiate either image as many times as you like. These image files, NetNet explains, have a .gif at the end of their names, which means that they're GIFs, or GIFs, or GIFs. The GIF, NetNet goes on, is a very special image format, what net artist Olia Lialina has called the spirit of the web. It was the first format actually supported by the IMG element when it was first introduced. GIFs were actually created for the web. They didn't exist, this image format didn't exist before for the web. Despite its limitations, or maybe because of them, it's remained one of the most popular formats for online content, embraced by early web makers to formal artists to all manner of creative folks in between. Now, all of these are links that'll take you deeper into the world of GIFs and that history of that culture on the web. I'm not going to click on these links because otherwise we'd go down on tangents, but I'll remind you here that if you visit netnet.studio and you launch this annotated demo, you can go through all of the links and navigate this however you'd like and mess with the code, etc. But I'll move on. Netnet explains that there are other image file formats that we can assign to an image element. It's not just limited to GIFs. Each has its own pros and cons. Generally speaking, you want to choose an image format that will look good while also being as small as possible. And by small, we're not talking about the dimensions, like the width and height of the image. NetNet's referring to the amount of data stored in the image file, so like the file size of the image. This GIF, the dancing girl GIF, is 5 kilobytes, which is pretty small for an image. GIFs are often very, very small. So that means it can transfer quickly over the internet. You might recall from the previous videos that websites are hosted on computers. Those could be your own computer, or those could be a computer in a data center. And then they're visited, which is to say those sites are requested by other people on other computers through their browsers. So all of the data on your website, not just the HTML file, but any media assets like images or videos that are part of your website, need to get sent over the internet to the other computer, which means internet speeds matter. And on a kind of average internet speed, you probably don't want your images to be more than, say, 5 megabytes in size. If you have a web page with too many images that are much larger than that, it'll likely take a few seconds for it to load on the other end as the images transfer from the computer hosting the website to the computer visiting the website. So this is why we generally want to make the files as small as possible, and this is where file formats matter. NetNet explains that GIFs tend to be real small, even when animated like these, but they're not great at storing high-resolution images. If we wanted to include, say, like a photograph that we took on our web page, it would be wiser to use a JPEG, JPG or JPEG, which are great at keeping photos looking high quality while also trying to keep the file small. Maybe not as small as a GIF, but small enough to transfer pretty quickly over the web. A GIF can contain colored pixels, but it can also be transparent, or it can have transparent pixels. That's why GIFs look really nice when you kind of start stacking them over each other on a web page, because you don't see the boxes, the edge of the actual image square, because some of those pixels are transparent, so you can see through them and they kind of get overlaid on whatever you put them on top of. A JPEG, however, can only contain colored pixels. If you have a high-resolution image that needs to look crisp but also has transparent parts, then you're going to want to use a PNG or PNG image. Like GIFs, PNGs can also be animated, and they actually support varying degrees of opacity. A pixel in a GIF can only be one of a specific set of colors, and when it's transparent, it's fully transparent. But a PNG can have gradations of transparency. You can have pixels that are somewhat translucent, somewhat opaque. GIFs do not, don't have that. All right, like JPEGs, PNGs can display photos perfectly, can do high resolution images, but there's a trade-off, and that's going to be the size. PNGs are usually much larger than GIFs and JPEGs, which means they'll transfer slower over the internet. So you generally want to avoid them unless you need a high quality image that also has transparency. Then the trade-off is going to be worth it. So these are the most common image file formats that you see on websites, but there are others that you can use with this IMG element, like the AVIF image format, or increasingly popular WebP format, and the infinitely scalable SVG format. We talked about SVG before. SVG is also a coding language, but you can, when you create graphics with SVG, you usually store that code, that SVG code, into a file with a .svg extension. And because that's a language used to create graphics or an image, you could load SVG files in an IMG element, right, by passing the URL to that file into the source attribute. We'll talk more about SVG, though, in future lessons. So the IMG element isn't the only element in this demo. Notice .NET points out that there are 4 rows of visible images in the rendered page. Let's change the layout like we discussed last week so we can see this a little clearer, right? See, we've got 1 row, 2 rows, 3 rows, 4 rows. And this is because they're laid out this way because images are inline elements, which means that when we write them one after the other, they're always going to show up next to each other on the same line. Let me go back over to this layout so we can see this a little clearer. So in order to break them into those separate rows, what we've done here is we have these BR elements. The BR element is also a singleton. It doesn't have a closing tag. It's just the opening tag. And similar to the HR, it creates a line break. The HR that we looked at before also creates a full line. It draws a line. The BR doesn't draw the line. It just creates the line break so that any elements that come after it are going to be on the separate line. And so that's how we were able to create these rows. These 1, 2, 3, 4, 5 images are the first row. They're next to each other. But then we have this break tag, which puts these next set of image elements, these GIFs, on the next row. Oh, let's go down here. Yeah, okay, so then it's pointing out these couple lines of code at the end. And it says, now take a look at this last row. Here's what it looks like rendered over here, which only contains 2 IMG elements, neither of which are showing up because I've intentionally misspelled the file names. Notice netnet left out the I in girl here. It says dancing GRL instead of GIRL. And since the image files are not written correctly, they're not getting loaded. When you write the path to a file, you need to write everything case sensitive, exactly every letter as it was written. Otherwise, the web isn't going to be able to find the file that you're trying to embed and load into the web page. The first image element is missing its alt attribute as well. Notice this one only has the source attribute. This is why it shows this broken image, this kind of icon that maybe we've seen on other web pages before when the image is no longer loading. The second image element, however, does have an alt attribute, so the page renders whatever you wrote in the alt attribute instead of that broken image. So in this case, it says Dancing Girl by Chuck Pointer, so that's what we see here, the text Dancing Girl by Chuck Pointer instead of the broken image icon. But this isn't the only function of the alt attribute. It's also used by assistive technologies like screen readers to read aloud the description for visually impaired users. Because of this, it's considered best practice and also has an impact on your SEO, your search engine optimization. This is why, although it's not technically necessary, netnet says that it'll make sure to warn you when you are missing that alt attribute. So this is why over here we see the little orange dot. If I click on this orange dot, and this will show up anytime you're working in the netnet editor, if you forget the alt tag or you make any other kind of mistake or don't conform to a kind of best practice, netnet's going to try to catch that, kind of warn you of that. Okay, let's return here to the guide. All right, that's the end. And it says now feel free to experiment with this demo, or optionally we can jump over to another demo for the audio element. So if you're following along yourself on netnet.studio, feel free to mess around with this and get a better sense for how these image elements work, but I'm just going to jump right into the audio element. All right, so let's walk me through the demo. Okay, so first thing that netnet explains is that the HTML audio element is used to embed sound on our page. We use that same source attribute that we used before when we want to load a specific audio file into our audio element. This is also used by the video element, which we'll look at in a second. Our page contains 3 audio elements, but only 2 appear visible because only 2 of them have the controls attribute. So notice this first one only has a source attribute, whereas this audio element has this controls attribute set as well as this one. So the 2 that we're looking at are the 2 with the controls. all three of the audio files are embedded in our page, but only two of them have visible controls associated with it. Why would we ever want an audio element that doesn't have controls? Well, because once we open the door to JavaScript, we could actually trigger those sounds using JavaScript and other kind of dynamic ways. We don't need these controls, but they're convenient if we just want to embed an audio file and make that easily playable for folks. The second audio element here has a third attribute, the loop attribute, which is what we set if we want the audio to loop at the end of it. So let me play that one here. Actually, let me lower this in case it's kind of loud. All right, so that's playing this electro-pop MP3 file. If I skip closer to the end here, you'll notice that once it reaches the end, it is gonna loop. It's gonna start from the beginning, as it did there, because we have this loop attribute present. Without it, it would just stop at the end. Oh, where'd our guide go? Let's open this back up. Unlike the source attribute, the controls and loop don't have values assigned to them, right? Notice there's no equal sign with quotes and some values. This is because they're known as Boolean attributes, which means it's either true or false. And by just putting in the attribute, that means we've set that value to true, and by removing it, not including it, that means controls is false or loop is false. Unlike the image element, the audio element has both an opening tag and a closing tag. Notice here, opening, closing, as well as the others also have their closing tags. This is because it can contain a set of optional source elements, not to be confused with the SRC or source attribute. Notice that the audio element has, in this one in particular, has two source elements, each with their own source attribute, right? So this one is pointing to katie.mp3, and this one is pointing to katie.ogg. What this is allowing the browser to do is kind of decide which of the two audio formats does it want to load, the MP3 audio format or the OGG audio format. We're also specifying, as netnet clarifies here, the type, so the browser knows what kind of encoding format, or what's known as the MIME type, these files used. I'll explain why this is necessary when we get to video, just to not kind of repeat the same point twice. But one thing that netnet points out here that's good to know is this website called caniuse.com. This is the first instance of something like this we've come across, but you'll see this over and over again, even with all the other languages like CSS and JavaScript, where sometimes there's a piece of code that may work in some browsers, but might not work in other browsers. And how do you know if that particular piece of code or that particular file format or what have you is compatible with certain browsers? Well, this website, caniuse.com. This is what everybody kind of goes to figure out, like, if MP3s are compatible, which browsers and which versions. Or what about that IMG element? This is compatible pretty much everywhere except some very old browsers. So caniuse.com, that's a quick place you can go to kind of look up if a particular file format or code is going to work, and if so, on which browsers is it going to work in. Why would something work on some browsers and not others is what we'll get back to in a second as we talk about video elements. So let's jump into that one next. Again, we're kind of at the end here of this second guided demo, so we can stop and experiment with the audio elements ourselves, add other stuff to this page, see where this goes, maybe even remix it into our own project. But I'm going to jump into the last annotated demo for this video, which is the video element. All right, and ask netnet to walk me through this one as well. So first it says that, as the name implies, the HTML video element embeds videos on our page. Like the IMG and audio elements, you supply the file to load via the source attribute. So here we see the source is set to screensaver.mp4. We also notice that we've got the controls and loop set on that one as well, which we learned in the last demo, are how we create these visual controls, right? So that we can actually hit play on something. And also how we ensure that this just loops back to the beginning when it gets to the end. And then here, again, we see something similar to the audio element. Just like the audio element, the video element does have a closing tag. The image element, which is a much older element, it's been around for a lot longer than the audio and video element have in HTML. The image element is just that singleton. Reason being that the content for an image element is the data coming from an image file. So why do we need that closing tag? We're just going to point to that file in the source attribute. But for video, though we can use it that way, pointing to the file in the source attribute, we could also, like audio, have these different fallback source elements that point to different versions of the video. So this is all the same video. If we were to watch these 3 videos, what you would see is the same thing, but they've been encoded as different file formats. One's an MP4, one's an OGV, and one's a WebM. As netnet explains here, each source points to the same visual content encoded in a different format, denoted by their different file extensions and MIME types. The browser scans the lists and picks the first format it knows how to decode. The first option is an MP4, which uses the H.264 compression, the OGV, which uses Theora, and then WebM, which uses VP9. As we discussed in our lesson on the platform, and also as I mentioned in the orientation and previous videos, the web itself is built on open standards rather than owned by a single company. These standards, like HTML, are developed by the W3C. Whoops, that's for later. Where am I? Here we go. The World Wide Web Consortium, a group where anyone can participate and help shape the language. This process is open and democratic, but sometimes slow or messy. But it's what ensures that the web belongs to everyone. The source element is a historical reminder of how messy, but also democratic, the process of making web standards can be. In the early days of HTML5, that's when the video element was introduced, browser vendors couldn't agree on a single codec. And I link here to an article from that era, which was sort of talking about that drama happening at the W3C, which again, I'll remind you, anybody can join the W3C, including companies. And at this time, there were a few companies who all had vested interest in certain video formats, and they wanted their video format to be the default video format for the web, and that would make them money. And other folks in the W3C, most folks I'd say probably did not like that idea. They wanted things to remain open. They didn't want browsers to be stuck having to pay royalties to one set of specific companies who maybe owned a particular codec. So this was the compromise. Web developers were told to provide multiple sources in different formats. That way each browser could pick the format it supported. So if Apple with Safari only wanted to play videos with a video codec that they owned, then your website would know, let's load the one that works on Safari. But if you were visiting, say, on an open source browser like Firefox, and they wanted to use an open source video codec, your website would also work on that browser because it had all the sort of fallbacks. This was frustrating, this was annoying, and this is also why sites like YouTube came in handy, because you would upload a video to YouTube, and then YouTube would give you not a video element to put on your website, but an iframe, which we'll talk about in a second, which was essentially a way of embedding their website into your website, a full screen version of the video streaming from YouTube. And behind the scenes, YouTube would take whatever video format you uploaded and convert it into all these other formats so that it would play across all the different browsers. Fortunately, that is no longer the case. Fortunately, MP4 kind of works on all the browsers these days. As I mentioned before, you could always visit Can I Use if you want to be absolutely sure that some format is going to work. But that's why this tag up here works just fine, and we don't really need all these other source attributes. Still, it's in the demo because it's important to understand, not just for technical reasons that may come in handy if you're using some esoteric browser on a project sometime, but also to remind us that the web is a commons. As I mentioned at the start of this video, there's no one company or country or entity that controls it. It's anybody who cares enough to participate in the W3C can join a working group and can have a say in the direction of this medium. Okay, let's quit this guide. Let me just create a couple elements here to remind us. We've got the IMG element, which we can use our shortcut snippet to autocomplete. We can put any image file there that is hosted on the web. We can host our own media files on our projects. That's something I'll cover in the next video when we talk about creating our own projects and publishing it to the web. That's coming up next. But for now, I'll just point to an image elsewhere on the internet. So here we have this URL that's going to a cat image. I know that this is a URL to a cat image because it ends with .jpg. If it ended with a .html or even just a word, that means that that URL is pointing to a folder likely with an HTML file in it. And so that URL is going to try to open up a full website. But if you have a URL that ends with an extension associated with an image or video file, then you know that's a path to an image file hosted on a server elsewhere on the web. And that's a path then that I can paste here into the value of the image element, and now I've loaded that image into my page. This image is hosted in Wikimedia servers, but I can pull it using the web, using this URL into my image element and have it become a part of my website. So I can have images, I can have videos, I can have audio as we saw earlier, and I can even embed other websites into the my page. This is where we start to get a little bit, metamedia. So using these other elements, we can get these already existing forms of media into our web pages, but the not yet invented forms of media, here's how that starts to become a reality. One is through the iframe. So an iframe has an opening and closing, just like the video and the audio, and just like all those other elements, has a source attribute. What we point this element source attribute to is not an image file, a video file, or an audio file, but another website. So it could be, say, my personal website. HTTPS. Now I have a little box here where my personal homepage is now embedded within this page. Again, this is how Vimeo or YouTube or SoundCloud embeds work. They usually give you a little iframe code that you can use to embed your video or audio player in your own website. And what they're doing is actually, there's a whole little website on their servers behind the scenes that's getting injected into your website in this iframe. This is a tiny little square. We can make this square bigger and smaller with CSS, which we'll get to later. But for now, the concept here that I want you to understand is that as a metamedia format, the same web page can include text, images, videos, even other web pages. And those other web pages can have new forms of content on them, like 3D stuff, or even an entire video game can be embedded in your website using one of these iframes. And if that's not enough somehow, we could even create our own HTML elements. And there's a couple ways to do this. As I mentioned earlier, you can join the W3C and you can propose a new element. You can say, we're starting to see devices with scent emitters, and I want to have smells on my website, and so we need a smell element that I can point to my smell files so that people can smell my website. You know, if you make a good enough argument to the rest of the working group, that'll become an official part of HTML. But if you can't wait that long and you want to create a brand new element now, there's an API for that. It's built into the browsers. We need some JavaScript for this, so I won't get into this until we get to that part and we start talking JavaScript. But you can use JavaScript to create what are called web components or custom elements and define your own element that doesn't exist, but that can work in HTML if you import the library that you made. So for example, there's a library called iframe, iframe.io. Which you can import by adding a script tag that points to this library in your web page, which lets you create 3D, augmented reality, and VR experiences right in the browser. Here I have a netnet sketch with some 3D objects in it, and not just 3D, this is fully immersive VR. If I had a VR headset and I visited this website with my VR headset, I can walk around these elements. And this is being created in HTML, but elements that don't exist as part of the normal HTML roster of elements. This has this a scene element and this a box, a sphere, a cylinder. And these are all possible because we've imported this iframe library with this line of code. If I comment this out, none of this is going to work because it's not all native HTML by default. But by bringing this one line of code, we're importing this new set of HTML elements that otherwise wouldn't exist, and now we're expanding the possibilities of this metamedia into that not yet invented form of media. I mean, AR exists, but you can imagine this can be used to create all new forms of media that didn't previously exist. That we'll get to when we talk about JavaScript, but I'll end this video there for now. In the next video, we'll start looking at how we can use NetNet, not just as a platform for learning, as we have been in the previous videos, but also for creating our own websites and publishing it directly to the web.